Okay, I thought I had made a video about this, but apparently not. At least I'm not finding it, so I'm going to make it again. This is the little Arduino. I'm powering it from the computer because my little battery, I lost my negative. And I don't want to deal with it right now. So I'm going to power the Arduino from the computer. Plug it in here. Power the drivers with a 10-volt battery. And let's see if everybody's going to work today. Yeah, look at that. There it goes. We have liftoff. Okay, now the thing about this is, I believe I have the Arduino all programmed, but I'll have to put it together and find out. Okay, so what I have here, let's leave it running. Okay, so the Arduino is getting the signal from the infrared, and I've got, you can see little amplifiers there that come in from the infrared receiver, and it goes into they're amplified, and I'm looking there they are, and they go into the Arduino, and the Arduino takes those signals and sends it to the FET driver here, which drives the FETs. And we've got one high FET and one low FET. And now I'm only running on half of everything because I only have one driver here and one set of FETs. I haven't, let me draw that real quick. So what you have is a high FET, and I'm going to draw them like transistors just to make it easy, and then the motor or the coil, and then a low FET, and this goes to ground, and this goes to VCC, and the two controls are set to where when the commutator, the little timing circuit, it's got a hole, and the infrared light shines through there, and it tells the controller, the Arduino, and the Arduino turns these two on. And I'm not sure, I don't remember offhand, one is maybe a positive and one might have to be a negative, zero, turn it, you know. Oh, actually, this is a N-channel FET. One of them's an N-channel, one is a P-channel. So this is showing an NPN transistor and a PNP transistor. So one of them, this really takes a low to turn it on, and this one takes a high to turn it on. So that's what we've got set up right now. We've got that little driver there that takes the input from the Arduino to drive these. Okay, so now what's next is I've got to add another driver, and I've got to add another set of FETs, which, yes, I'm drawing transistors, and it's going to be the same situation except opposite. Right now it's just pulsing the current one direction, and what will happen is there's two holes, and well, there's more than two holes, but it'll pulse. There's two infrared devices, and it'll pulse one way, and then when the magnets come back around, then it'll pulse the opposite direction. It'll change the direction of the current when these turn on. These will be off and these will turn on, and it'll change the direction. And so it'll, I want to call it full wave control, is what we're working on here. And you'll see it'll have one set here and one set over here, which is going to lead on to the next step, which is going to be using it to build a complete, what do you want to call it? Good grief. The sine wave, which uses 3 of these setups, and the Arduino will generate these pulses, which look more like that. There'll be 120 out. And this is how a regular brushed DC motor sine wave works, whereas this is just a pulsed motor. So a pulsed motor running on half a phase, I guess. So it's running. I blew up one of these drivers the other day because they're supposed to be 18 volt tolerant, or 20 volts, and I put 18 volts on it anyway. I blew it up. What I have to do is get a voltage regulator so that I can jack this voltage up here. And I have a voltage regulator, I think. I might have to get a 5 volt voltage regulator. And that's another story altogether. To jack up this voltage, and what I want to do is be able to run it off of 36 or 48 volts, but you can hear it changing speed there. So it's working quite nicely now. I'm very happy with the progress. Sometimes things come slow, but persistence pays. Tongue twister.